Welcome back, guys. Good morning to everyone, and I've got my Bruce Lee coffee. What we are going to do today is we're going to look at a basic demonstration that I wrote several years ago called Halloween. I talked about this demonstration a little bit in my video where I talk about display lists. I'll link it down below. But this gives us an opportunity to come back and do some basic and assembly language programming because I left a flaw in this demonstration. It's not really a flaw, but it's a super inefficiency, and that is the demonstration actually it's called Halloween, and it loads up some images from the disk and flashes them on the screen like a spooky night and also a picture of Michael Myers, and there's some thunder and some sound effects going on. But those of you who have watched that video before know that that demonstration takes several minutes to load up and then actually start executing. The reason why it's so slow is because it's using the stock Atari BASIC file, open, and get commands. And basically when you're getting data from a disk using those rudimentary basic get commands, it's reading it 1 byte at a time from the drive instead of streaming like a block of data, like 128K bytes from a sector or 256K bytes from a sector at once. It's very, very slow. So let's load that demonstration up and run it. And I'm going to time it, and I'm going to show you how long it takes to actually load those images into memory and then actually start executing the demo. So here we are at our Atari. Let's load the source code for the old version. It's loading from my Side 2 cartridge today. I'm using the Side 2 cartridge. Okay, so here's the code. And it's a good sized program. And we'll use this program on and off to teach certain aspects of programming the Atari and BASIC. All right, so I'm going to go ahead and run this program. Actually, before I run this program, I think there might be 2 file names that I have to change because now that I'm using the Sidecar 2, the partition that I'm saving my BASIC programs on is actually drive 3. I think when I wrote this program, I was using the Atari 1050 disk drive, which is drive 1. Let me see, yeah. So here's the first part of the code we have to change right away, and that is instead of reading from drive 1, we need to tell it to read from drive 3. Now this is the first image. This H4.gr8, that's the first high resolution image, which is the spooky night background. The second image is the Michael Myers picture, which is right here, a few lines down. Michael.gr8. So let's change that also to go to drive 3. Okay, now we're ready to go. So let me bring up my stopwatch and let's run this. And let's see how long this takes to load. So you can see it brings a loading message down at the lower portion of the screen, and then over in the top part you'll start to see little bits of the picture showing up. That's slowly, byte by byte, loading from the not only the disk drive, but it's loading from the flash memory, which is the Side 3 cartridge. So let's let this go and see how long it takes to actually load these 2 images. Now the first image, the spooky night, is actually being drawn right to the screen. The second image is being read up into memory, and I use a trick in Atari BASIC with some assembly language to flash the images back and forth, and we'll talk about that another time. But let's see how long it takes to load this image. I'll be back. So we finally got it to load. Almost 6 minutes, guys. Which is nuts. Unacceptable. All right. So there you have it. Okay. So let's see what we have to do to speed this up with assembly language. Okay, so now let's take a look at the code and let's find out how we can speed this up. Now, we're going to focus right in the area here that does the loading. So let's break this down here for a second. Let's get rid of some of this code that we don't need to look at, and let's go up here and separate this a little bit. All right, so what we're doing here, what I'm doing here, is I'm setting this variable CT, which stands for a counter, and I'm initializing it to 0, and I'm also initializing a variable here called start. Start is a variable that I'm using to point to the place in memory on the screen that I set further up called pick ADDR top. Pick address top is in memory where the start of the screen is. That's the variable where the start of the screen is in memory. And that's where we're going to start putting the data that we're reading from the disk drive, okay? So now what we're doing, we can forget about these two comments. The first thing we're going to do is we're going to obviously open the file. Now we're opening channel 1. The mode is going to be 4, which means we're reading from the file. And here's our file name. This trap statement here does nothing more than catching the errors. We really don't need it here, but it's there. I put it there originally. But here's the trick right here. This is where everything gets bogged down. In Atari BASIC, we have what's called the get command. Okay, the get command is used to get data from the disk. And what you do is you pass it the channel number, which in our case is number 1, and then you give it a variable named D, and that is where the get command is going to place the characters that it's reading from the disk drive. So when this call gets executed, get number 1 comma D, it's going to go to our file, get the first byte, and put it in the variable D. Now, immediately we want to put that piece of information on the screen. So as you see the image being drawn slowly, we're getting a byte and then we're putting the byte on the screen column by column by column. So what this poke does, it says, okay, at the start of the screen, plus the counter CT, CT is at 0, so we're literally at the beginning of the screen, the first pixel, the first character, if you will. Go ahead and put that character on the screen. And then as soon as we do that, we're incrementing our counter. So counter is going to go from 0 to 1. And so on. So as we go through this loop, we're going 1, 2, 3, 4, 5, 6, all the way up to, I know that happens to be 3519 because I calculated it ahead of time, 3,519 characters we want to read from the file. This next line says, if the character variable is greater than 3519, then we're going to reset it to 0, and we're going to set our start variable, which is, again, where we're shoving data, to pick address bottom, BOT. Now, this is something I'll have to talk about in another video, but when you're dealing with graphics mode 8, it's 320 by 200, okay? And that's basically the way that it works out for the display list is you can't write all of that information in one contiguous block of memory on the screen. So what ends up happening is when you create your display list, the display list specifies lines 1 through whatever half of the 320 screen is. And then inside the middle of the display list, there's a jump command that you have to tell it, okay, where is the next part in memory that we're going to display the other half of the screen? So when you're dealing with graphics mode 8, you have to have it in 2 chunks, if you will. So what I'm doing here is I'm reading the first chunk, bytes 1 through 3519. I put those on the screen. And then you'll see in a second here, we reset the counter and then we read the second chunk. But in any event, what are we doing here? Let me go list some more of this. Okay, so let's go back up here where we were checking to see if it's greater than 3519, which it's not going to be initially. So what we do is we go back to 460. 460 comes back up here, reads another character, puts it on the screen, increments the counter, does our check, and so on. So we're looping through. We're reading one character at a time, putting it on the screen. So up here, we're doing that for the first half of the screen. And then once that counter reaches 3519, it resets to 0. It sets the start to the beginning of the second address in memory where I have the bottom part of the image. And then we kind of do the same thing over again. We're reading a character, we're poking that character, now starting at the middle of the screen, going to the bottom, and so on. So we're doing 2 loops here, reading the top part of the screen, reading the bottom part of the screen for the first graphic, and then poking it to the screen. And you can see it's just a very slow process. Now, once we get done with the first image, which is the spooky night, we close that file here at line 510. We reset our counter again, and this time we're setting the start variable to pick2 address top. Now, higher up in the program, I have pick2 address top as an area in memory where I can store the Michael Myers picture. So pick address top is the first image. Pick2 address top is the second image. And so let me reset this guy. Let's list these lines. So basically I'm doing the same thing I did for the main image, but now with the Michael Myers picture. We're opening the file here, same before, open channel 1 for read. This time we're opening Michael.graphics8. We're doing our get again, character by character. We're poking it to the screen, incrementing our variable, and so on. And we do 2 loops of that. So let's see. How many lines are we talking about here to get this done? So we're actually starting here at line 420. Right? So let's count. Let's see how many lines we got here. So from 420, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, up to 510. And then let's see, 511, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29. So 30 lines of code, roughly, to get the 2 screens loaded into memory. Now, obviously, we can optimize this. We could put more characters per line, and we can crunch this down. But for this particular program, we're looking at 30 lines of code. So, you know, I know there's going to be guys out there saying, oh, you can condense that down. Yes, you can condense it down, but it doesn't make a difference. It's a voluminous amount of code to get the job done. So now what I'd like to do is I'd like to load up a modified version of the program that I did earlier. So let's take a look at this version of the program. Okay, so let's go look at the area of the program where we're loading the graphics. Okay, so we're starting here at line 400. So let's go talk about this a little bit. Actually, we're starting right here at 420. So same as before, we have to open the file, okay? But now you can see down here, instead of all those CT variables and the start variable and the get command and the trap and all that hooky-mooky stuff, we've got some pokes, okay? Now I'm going to talk about what these pokes do, but in general terms, this line here, 425 through 445, 1, 2, 3, 4, 5 lines of code will read the first half of the screen, and then these next 1, 2, 3, 4 lines of code read the second half of the screen. So we went roughly from 15 lines down to, what are we talking about here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 lines. It's quite a bit of reduction. And we could actually bring it down a lot more if we wanted to. But more importantly, the speed that we're going to get, you're going to see. As a matter of fact, let's run it. And let's watch how fast this demo loads and runs. It's done. So what did that take? 2 or 3 seconds versus 6 minutes that the other version did? Let's see that again. Now, when you run it, it takes a couple seconds to initialize some of the memory and the variables, but overall, there it is. It's running. So that's a huge speed up. That's a dramatic speed up just by putting those few lines of assembly language in there. So let's break down what we did. So the first thing we have to understand is what I'm doing here is we're using a part of the Atari's operating system, or the basic input-output that's built into the ROM, called the CIO, the Central Input Output System. I talked about this before in another video called Hello World that I wrote in assembly language that basically writes the string hello world to the screen. It does that using the CIO, the Central Input Output System. I highly recommend you go watch that video if you want to know more about how the CIO system works. But just in general terms, the CIO is a generic way of getting data in and out of the computer. It was really, if you want to think about it, it was way ahead of its time in the fact that you could read and write to any device that the Atari you could connect to on the serial input-output device. Devices like disk drives, modems, printers, the 850 serial device. The CIO is a generic way of getting data in and out, and the way you work the CIO is you set up what's called an input-output control block. There's 7 of them. When you do the open command here in BASIC, open number 1, and you're opening a file, you're actually using block number 1. You just don't know that. But what we're going to do is we're going to go right to assembly language. We're going to modify and adjust input-output control block 1. We're going to tell it how many bytes we want to read. We're going to tell it where in memory we want that data to go. And then we're going to make a jump call in assembly language to the vector or the location in memory that executes the code to read the data from the device. All right. So let's talk about the CIO. And I should have a graphic up on the screen here where we talk about we're going to be using input-output control block number 1. Now, if you look on the screen, input-output control block number 1, I have it listed in hex and decimal. Starting with decimal 848, we're going to start poking some of the values for that input-output control block 1, and we're going to put the numbers in there that we want so that when we make the jump call in assembly language, it's going to read our image up from the disk. So let's specifically look at the bytes that we're going to be using for the input-output control block number 1. So the first locations that we're going to change are locations 852 and 853. Okay. Now 852 and 853 are it's a 2 bytes that we're going to be setting. The first byte, 852, is the low byte in memory, okay, of the memory address where we want our first picture to go. 853 is the high byte of the memory address where we want our picture to go. Now you have to remember in the Atari world, you've got a memory address which is 8 bytes and 8 bytes, which is a 16-byte address, okay? But the Atari can't store a complete 16-byte address. It can't access, well, it can access, but it can't store 16 bytes in one location in the memory. It has to break it up into 2. And these 2 bytes, they're reversed in the Atari's memory. So in other words, if this is the high byte and low byte, when you look at it in memory, it's actually the low byte first, and then the high byte. So when you're dealing with the Atari, you have to always remember that when you're addressing or you're referencing a 16-bit address, you have to swap the bytes and put the low byte first and the high byte second. So that's the reason why I'm poking here. What I have stored in the picture address top low is the low byte, and then I'm poking in 853 the high byte. So this is the address in memory. Remember I talked about the beginning of the screen, the top left-hand corner of the screen where we want to start writing our image? We're telling the input-output control block, that's where I want you to start putting data when you begin reading from the file. Okay, the next two bytes in the input-output control block that we're going to fill is 856 and 857. Now, 856 and 857 refer to how many bytes we want the CIO jump call to read, okay? So what I've done is I've placed in the low byte 191, and I've placed in the high byte 13. These 2 decimals, high byte, low byte, represent the number 3519, 3,519 bytes. I'll put a graphic up on the screen that shows the breakdown of how you go from 3519, you convert that to hex basically, and then you take the 2 hex numbers and you reverse those, and those become your low byte and your high byte, okay? Now, the next value of the input-output control block that I'm going to fill is location 850. 850 is the mode, okay? And just to be safe, what I'm doing is I'm setting the mode to 7. 7 tells the CIO that we're going to be reading in binary. Now, here's where the magic happens right here on line 445. Now, I've got a video where I talk about the USR command. I'll link it in the description. This is how you can call assembly language routines from Atari BASIC. This stands for user subroutine. And what you do is you pass in parentheses a string that represents, or you pass it an address in memory where you want to execute your machine language code. Now, inside these this entire whole parentheses, what we're doing is we're saying, okay, run the user routine, and normally we would have an address here, but what I'm doing is I'm telling right now in BASIC, go ahead and get me an address for this string. I'm doing this real time within the parameter of call user subroutine. So what I can do is these funky looking characters here, if I translate these down to actually decimal numbers, which I'll show on the screen now, these are actually the bytes in assembly language, the opcodes that actually run our assembly language routine. So the 3 H's, these end up being PLA. These reference the PLA command in assembly language. And then the asterisk is the transfer, the accumulator to the X register. And then our jump call to the COV, which is E456 if I'm not mistaken. So these 1, 2, 3, 4, 5, 6, 7, these 7 characters are the few lines of assembly language code that we need to actually call the operating system to tell it to read the data from the disk. So what this is doing basically is it's saying get the address in memory of where you're storing this string, and BASIC is going to arbitrarily put this string somewhere in memory when we run the program. And this says give me the address of it wherever you're putting it in BASIC, and then execute that code, meaning execute the machine code. Now, the USR command takes an address as its first parameter, which is this entire block of code, comma, you can pass parameters into the machine language code, and this parameter 16, what that's doing is it's basically transferring into the X register the value that we need in order to make the jump call on the CIOV. Okay, so this one call right here is basically executing the assembly language code that says read the data from the disk and follow the instructions that we did up here as far as where in memory I want you to put it and how many bytes I want you to read. Okay, and that happens blindingly like in a second. So we're doing 2 of these codes. I'm setting up the block up here for the top of the first picture, and then I'm doing it again down here for the second half of the screen for the first picture. And then if we continue, okay, so we've got the first block, and then down here you can see again I'm doing the same type of operation here, except now we close the file, and now I'm opening the Michael Myers graphic, and then I'm doing the same thing. I'm setting up the input-output control block, where in memory I want to put it, which in this case is a new point in memory, pick 2. Let me show you where I'm setting these. So I not arbitrarily, but I planned out some points in memory where I store these pictures. So the top half of the image, the Spooky Night memory, the Spooky Night image, I'm storing an address 4000 of the Atari's memory, which translates to in decimal 16384. Okay. The bottom half of the picture, I'm putting in location 5000. And then the top half of the Michael Myers, I'm putting in 6000, and so on. So that's how I got those values. I'm setting those up in the top of the program. Okay, so basically from here down to here, it's a very short line of code. This is where we're reading the 2 graphic files up using machine code and putting them in memory. So let's watch it again, how fast this is. There, we're running. Okay, so just that fast, we loaded 14K of images, initialized our code, and here we go. All right. So anyway, guys, that's what I wanted to show you today. And as a matter of fact, before we do anything, what I'd like to do is I'd like to let's type up a quick, simple program of writing data to the disk in BASIC, and then we'll use this same routine to read it back. This will further demonstrate how fast we can read data from the disk using assembly language. Okay, so real quickly, let's create a quick program that just writes some characters to the disk. So let's do an open channel 1 for write, and let's call it test.dat. Okay, then let's go ahead and let's put, I don't know, let's put the letter A, which is an ASCII 65. Well, before we do that, let's make a loop, because we want to write a bunch of characters to the file. So let's go for x equals 1 to 8194. Let's write roughly 8K to the file. Next x and 40. So what we're going to do here is we're going to open a file for write. This should be an 8, because 8 means open and create. Okay, so we're going to open a file for write. We're going to call that file test.dat on drive 3. We're going to make a for loop 8,195 times, and I got rid of the, we need to have this line, put number 1, comma, 65. So we're going to loop 8,194 times. We're going to write the character A to the file, loop through, and then close the file. So let's run this. This is going to take a few seconds because, again, we're not going through assembly language for the writing. What I showed you today was how to read fast in assembly language. We can actually translate this to the writing. I'm not going to do it right now. I'm just going to go ahead and let this write the characters to the file. So let's let it do what it's going to do. It shouldn't take as long as the program did the demo to read the characters, because we're not doing any poking and displaying it to the screen. So let's see. Let's wait for this to finish. Atari BASIC is so slow. All right, so there we go. Now, just to confirm, let's go to DOS. I actually want to view that file and make sure that it did what I think it did. Okay. Let's type that file to the screen. Yeah, so you can see here we've got a huge 8K file just full of the letter A, which is fine. That's all we wanted for our test. So let's go back to BASIC. Let's type new. Now let's write the program that reads it, but we're going to use the assembly language routine that we did before. So let's open the file. We're going to open it for read, and we're going to call that test.dat, because that's what the file name is. We need a place to, since we're not reading and writing it directly to memory, the screen, like we did before, we need a place to store this information as we read it up. So I'm going to create an array of 8,194 characters. Now, in Atari BASIC, when you dimension an array, that area in memory is not actually allocated until you use the array. So in order for that space to be pre-allocated, which is what we're going to need when we read all of that data from the file, we need to go through a loop, unfortunately. And basically, just in this case, we're going to go one character at a time, and we're going to assign a blank character to it, or a space. Now, this loop in itself is going to take a matter of seconds to run, so that's going to be one little bottleneck in the program. And actually, to show how slow that is, what I would like to do is let's put a print statement here in line 25 that we're clearing the array. So at least we know what's happening. And line 40, let's do a print reading file so we know when it actually starts to read the file. Okay. So the next thing we want to do is, if we're going to be storing data from this file into this array in memory, we need to get the address of the array. Okay. So what this command ADDR does in Atari BASIC, it says, give me the address in memory of the variable A string. So it's going to assign to our variable ADDR some number in memory that the Atari BASIC has stored that. Now what we want to do is, since we're dealing in assembly language, remember we're going to be using the input-output control block. We need to use low byte and high byte. So we need to break down the address in memory where we're going to be shoving this data. Before, it was that picture top address that I showed you. In this case, it's going to be this Atari array variable. So what we want to do is we want to set up a couple of variables here. One we're going to call one high, and that's going to be the integer of the address in memory divided by 256. Why do we divide by 256? Because in the Atari memory, the memory is laid out in what is called pages, and each page is an even byte count of 256. So one page would be 256, two pages would be 256 times 2, 3 pages times 3, and so on. So to get the high byte, you basically take the integer of the address divided by 256. The high byte is a rounded, clean integer of the number of pages in memory for the address. And then what we're going to do is we're going to say the low byte is equal to the address in memory minus the high byte times 256. Can't type today, guys. Okay, so that's going to give us the low byte. Now we do just like we did before in the demo program. We're going to poke address 852. And here we want to specify again the low byte in memory where we're going to be putting the data. And also in the high byte, we want to put in here the high byte of where we're going to be putting the data. Okay. Now the next thing we need to tell it again how many bytes we'd like to transfer. So we're going to do again like we did before. 856, we're going to poke 2. And 857, we're going to poke 32. And then in 100, we're going to tell it, again, we want to read in binary. And then 110, we're going to execute our routine like we did before with the 3 lowercase h's. And then we had the inverse ATASCII asterisk. And then we had the uppercase L and V. Oops. What did I do? L and V. And then we have the inverse lowercase d. And then 16, which tells it that we're using CIO block number 1. And then we're going to close our file. Now let me save this before I lose it. All right. So what do we have? So we're opening the file. We're dimensioning a string, A string, 8K. We're going to be clearing the array. And then we're going to start reading the file. We're going to get the address of the array. We're going to get the high byte. We're going to get the low byte. And then we're going to tell the input-output control block where in memory we're putting this with 852 and 853, how many bytes we want to read with 856 and 857, and then we're executing the code. So what we should end up with is we should end up with that file that is 8K full of A's into our array variable A string. So let's run it and see what happens. Okay, so the first thing we see here is that it's clearing the array, and that is a slow operation because we're using Atari's 4next looping system. But as soon as that's done clearing the array, we should get the string reading file, and it should be no more than a second or two before it's done reading the file. Fun, fun, fun. Okay. Did you see how fast that? It printed reading file and immediately gave us the ready sign. So let's print our array. Oh, we got a bunch of blanks. What did we do wrong? Okay, so I figured out I missed one line here. This is the reason why it's so important that you get these exactly right. I forgot to put into location 850 a 7. Because remember, when we're reading data in assembly language, we want it to always read the data in binary mode so that it gets the exact character from the file. So let's run this again. Clearing the array. I'll speed this up. Just like that, it read the file. So now, let's print the context of our array variable. And there we go. A's across the board. All right. So there we go, guys. Reading files in BASIC using assembly language. So I hope this quick tutorial was useful, and I hope that you practice your assembly language in a BASIC using this technique. I'm going to leave the source code for all of these examples on the website, 8bitandmore.com/download. I'm going to call the Halloween demonstration that's been upgraded, it's going to be Halloween Fast. And I'm going to call these two programs Test Write and Test Read.bas. So you can download both of those and try them yourself. So that's it for today. Hope you liked the video. Make sure you subscribe. Make sure that you hit the like and hit the bell. That's going to let you know whenever I have new videos released. And consider joining the channel. It's 99 cents a month, which is cheaper than a bad cup of coffee. And it's going to help me produce more videos and continue going along with the series. And thanks for watching again. Share with your friends. Love you all. Peace.